So the final test in the project is going to be using this hook weight system. The idea of the third law of Newton's three laws of motion is that the third law is the action-reaction law. Basically, any action that is applied to one object or the action of one object affecting another object, basically, the other object will have an equal in magnitude but opposite in direction reaction. So with this contraption, the idea is that when I add weight to the bag, it will cause a force magnitude of it pulling down. And in this case, we are setting it as we don't know what the weight is. I have a scale, and that will allow me to figure out a percent difference, but with this experiment, we are just going to use gravity as a constant, and the weights, the more I put in, the more heavier it will be, obviously. But ultimately, the action is that the weights themselves, accompanied with the accelerational gravitational constant of gravity, will produce a force. And that force, in turn, is reacted by the hook and also this crank that I'm using to stabilize the hook. It will have the exact same amount of force as the weight's pulling it down as it is the hook weight keeping itself up, is the idea. Because if the weights were to be too much for the hook weight to handle, then one thing would really happen. The hook weight would break and would also begin to fall with the weights downward as gravity is pulling everything down. So this is just the video explanation of the test, and as I apply the weights to the bag, you'll see that the scale will begin to move, and then in the project you'll see the weight of one I have black cubes that I'm going to be using. You'll be able to see the weight of one black cube, and then using that we will then calculate the experimental weight of the black cube, and then comparing it to the actual weight, and then figuring out the percent difference.